Hello and welcome back. I hope that you had a easy time with the balancing of the reactions, and if not, I hope that you got the support that you needed in order to complete it, or if not, I hope that this video will provide you with the support that you need in order to complete the lesson 2 assignment. So here's the assignment here. I'm just going to go over some of these answers. This first part is just a straight fill in the blanks. So the first part is asking you to say what are the reactants in equation A. So here is our equation A. The reactants are the part right in front. So in equation A, it's H2 and O2. The reactants in equation B are the ones that are in the beginning. So that's MgCl2 and sodium. Now you could have included the coefficients for balancing if you wanted to. It's not right or wrong to include those. They just aren't necessary. So it's extra information. The products in equation A are the ones after the arrow, and in equation B, they're the ones after the arrow. So if I were to highlight the reactants in equation A and the reactants in equation B, the reactants are in green and the products are in yellow. So to answer question 2, the products is water for reaction equation A, and it's sodium chloride, which is table salt, and magnesium. Notice how magnesium is by itself there. It is not a halogen. It is not a gen, meaning that it ends with the word gen or the sound gen in its name. So when it's by itself, there's just one of them. All right. What do the coefficients tell you about the ratio of reactants? So looking at the green highlighted reactants in equation A, there is 2 hydrogens for every something oxygen. Now, if there's not a number there, the invisible number is a 1. So it's a 2-to-1 ratio because there's 2 hydrogen atoms or molecules for every, there's 2 hydrogen gas molecules for every 1 oxygen gas molecule. And for equation B, there is no number in front of that first compound, which means there is a 1 there. So it is a 1-to-2 ratio, 1 magnesium chloride molecule for every 2 sodium molecules. The next part says, what is the physical state of products in equation A? That's what that little thing in the, it's not a subscript, it's in little brackets, it's an L, so it means the water is in its liquid state as a product there. And for equation B, there is an AQ, which means sodium chloride is aqueous, which means it is in solution, it's salty water. And the S stands for solid. And it says write equation A as a sentence. So hydrogen, and if you remember that hydrogen forms a gas in its basic state, hydrogen gas reacts with oxygen gas. Then there's an arrow, so that means to produce. We could say yields to produce water. And to help you out, it actually does tell you that these are in gas form. So hydrogen gas reacts with oxygen gas to form water, or you could replace that with liquid dihydrogen oxide, liquid water. It's also just a lot easier to say than that. So for part 2, it says write the term that goes with it. If you haven't done this part, please pause the video and do it. This is for you to practice your skills, not for you to write down me telling you the answer. All right, so number 1, these are the whole thing, which are reactants. Number 2 is everything on the right-hand side of the arrow, which are products. Number 3 is looks like it is pointing to the S, which stands for solid. 4 looks like it's pointing to the coefficient, and nothing else seems to be pointing to the coefficient, so I'm going to say that's pointing to the coefficient. 5 looks like it's pointing to the AQ, which stands for aqueous. Okay. 6 is pointing to the yield sign, the yields, which we say to produce. 7 is pointing to the subscript, which we do not change when we are balancing. 8 is pointing to the L for liquid. And 9 is pointing to the G for gas. The whole thing is a chemical equation. Okay, this last part was the balancing portion of the assignment. Okay, so we have 2 nitrogens produce 2 nitrogens, and we leave the oxygen blank. So there's 4 nitrogens all in total, 2 oxygens in total. Okay, I'm just going to write the answers down. Okay, so if you were to go through this, you can pause it here and see how you did. But if you were to go through this, you would be balancing. And if for number 6, you go through and you say, okay, well, there's 1 CD, 1 CD, 1 carbon, 1 carbon, and there's 3 oxygens and 1 plus 2, which is 3 oxygens in the product side, it's already balanced. So you don't actually have to write anything. Now, if this was a test in class, you would just put the ones in, or you would write down already balanced. I'm going to go through this one up here. So you've seen the answer, but I'm just going to go through how I would do this one. So here I have 1 sodium and 1 sodium. I do have a hydroxide here, but I don't have a hydroxide in the reactant, so I can't treat it as a polyatomic ion. So I have to balance the hydrogens and the oxygens separately. So here I have 2 hydrogens, and I have 1 plus 2. I have 3 hydrogens on this side. There is nothing I can multiply with 2 here in order to get an odd number. So I'm going to go, okay, well, this is an even number, but this is an odd number. So I need to make the hydrogens in this compound even in order for it to balance in the reactant. So I'm going to put a 2 here. And then I'm going to say, well, I have 2 times 1. So I have 2 hydrogens here and 2 hydrogens here. So I have 4 hydrogens on the product side. So I need to make this be 4 as well, which means I'm going to add a 2 here. So now I go back to the beginning. I have 1 sodium here, 1 sodium here, and 2 sodiums here, because there's a thing here. There's a coefficient. Nothing. So I'm going to add a 2 in front of this. So I have 2 sodiums, 2 sodiums, 4 hydrogens, 2 plus 2, 4 hydrogens, balance. I have 2 oxygens, and I have 2 oxygens here. I am now balanced. Okay. Let me know how that went. I think, is there any more? Yep, there are. These ones have the polyatomic ions. So I'm going to balance these live for you instead of writing the answers down. So here I have 1 sodium and 1 sodium. I have 1 hydroxide, and I have 3 hydroxides here. So I'm going to place a 3 in front. Because I placed a 3 in front, I know that messed up how many sodiums I have. So I'm going to go back. I have 3 sodiums. I have 1 here, so I have to add a 3. So I have 3 sodiums, 3 sodiums, 3 hydroxides, 3 hydroxides, 1 iron, 1 iron, 3 chlorines, and 3 chlorines. So I am now balanced. So if I just erase all that noise, this is what it ends up looking like. It is a 3, 1, 3, 1 coefficients, order of coefficients. Looking at the next one, I have 1 Ca, 1 Ca. I have 2 Brs, and I only have 1 Br here, so I have to add a 2. All right. I have 2 sodiums. I have 2 sodiums. I have 1 CO3 here, and I have 1 CO3 here, and it looks like I'm balanced. So I'm just going to double check this one and go through right from the beginning to make sure that I didn't accidentally change something. So I have 1 chlorine, 1 calcium, 1 calcium, 2 Brs, 2 Brs, 2 sodiums, 2 sodiums, 1 CO3, 1 CO3. I am now balanced. So the order of coefficients on this is 1, 1, 1, 2. Okay. Let me know if you have any questions. I hope that helped going over them. I hope you're all doing well.